Hello everyone. Today we will see that how small g, which is gravitational acceleration, that can be varied with respect to depth of the earth. Let's say we have a mass m, and we represent it with small m, and we know that mass of the earth can be represented with me, and this is the center of the earth. So we know that the distance between these two bodies is, in this case, that is re, and we can say in this situation the small g on the surface, that is g, capital G, which is gravitational constant, and mass of the earth divided by distance between these two, and that is in the square. We can call it on the surface. Okay, now if we have in such situation, for example, if we displace this object to some height, for example over here, so now and the situation is a little bit different because we are at some height and we call it, let's say, h. Now the distance is, the total distance is re plus h. So now we can say that small g at distance r at height h, that will be equal to g, capital G, me divided by re plus h and whole square. Now we can call it at height h. Okay, now but we are interested in depth, so that is the topic of today. Let's say now we can go inside the earth, for example over here. Now we are at some depth and we call it, let's say from here to here we cover some distance d. Okay, now the distance is different from here to here, and that distance is re minus d. And at this point the mass of the earth will become, let's say we call it me prime, because it will change and we are inside the earth. So in this situation we will have g d at depth d, that will be capital G me prime, because now this is the different mass and we are inside the earth surface, and this will be re minus d. This is the depth square, and we can say it at some depth. But now we are not interested in me. We can say that let's say we call this equation 1, and for example this is equation number 3, and let's say we divide 1 by the second one. Let's say this is equation number 3 divided by equation number 1. So this will be gd, and that will be small g, and we can say capital G me prime divided by re minus d whole square. Clear? And this g will be in such situation re square divided by g me. This capital M will be cancelled out. Now we have me prime re squared divided by re minus d whole square and me. Let's say we call it equation number 4. So in further calculation we can say the density of this earth is, let's say, rho, and this will be equal to mass of the earth divided by its volume. In this case, for example, if we have mass of the earth, so we can say that mass of the earth will be equal to density into volume. And we can also say volume of the spherical shape is 4 by 3 pi re cube. This is for the total mass me. And for example, if we have me prime, so this will be equal to rho divided by 3 pi, and this will be re minus d whole cube. So equation number 4 will become like this. If we see, this is equation number 4. So we will put the value of me prime over here. So me prime is like this. This is gd divided by g. So me prime is rho density 4 divided by 3 pi re minus d whole cube, and divided by re minus d. This is re cube, okay, and sorry, square, not cube, square, okay. This is in square, okay, divided by re minus d whole cube square, and me in this situation density 4 divided by 3 pi re cube. So this term can be cancelled out. Density will be cancelled out with density 4 5, and divided by 3, this will be cancelled out with this, and this square will be cancelled out with this one. Here this square will be cancelled out with this one. So in short, we have re minus d, and this will be cancelled out as a whole, okay, divided by re, okay. So we can say this gd as g multiplied by, and this can be written as re minus d divided by re divided by re. We just separate this one, and this re will be cancelled out, so we can say g multiplied by 1 minus d divided by re. And this is the actually the acceleration at depth of the earth. So, and we can use it for many purposes.